Hello students, good evening everyone. Welcome to Infinity Learn by C₃H₄. This is me Surya, your chemistry faculty from Infinity Learn. And I hope I am perfectly audible and visible to each and everyone present over here. So those who are watching the session, just mark your attendance here. So finally we are moving to our last part of the chapter, carbon and its compounds. We will be discussing the last part about the two different types of carbon compounds. One is ethanol and other one is ethanoic acid. So these are the important points we are going to discuss in this particular session. The introduction to properties of ethanol, then the reactions of ethanol with sodium as well as the reaction of ethanol to give the unsaturated hydrocarbon. Then we are discussing about the ethanoic acid compound, right? Ethanoic acid compound, their introduction to the properties as well as esterification reaction, the reaction with the base as well as carbonates and hydrogen carbonates. So let's start with our first compound, that is ethanol. Hi Adil Nirban, good evening. I'm also fine. What about you? So here is our first compound we are going to discuss about the ethanol. So in the functional group part, we have already discussed what you mean by alcohol, right? So the functional group which is present in the compound is known as the OH group is known as the alcohol, right? So in the case of ethanol means two carbon compound containing an OH group or the hydroxy group, right? Okay, fine. So in general, the ethanol is known as the ethyl alcohol, right? Which means there is an OH group is present. So this is commonly known as ethyl alcohol, and it is a simple alcohol with the chemical formula of C₂H₅OH. So what you're observing here, two carbon atoms are present, right? So what is the word root? It will be eth. So with the OH group, it will be ethanol. Then what is the physical property of the ethanol? As you can see over here, it is a colorless liquid. Then volatile liquid. What do you mean by volatile? Which can easily vaporizable, right? Which can easily evaporated. That is known as a volatile liquid. With a characteristic odor and a burning taste. These are the physical properties of ethanol molecule or the alcohol molecule given here. Then this ethanol exists as a liquid under normal temperature condition. That's about our 25 degrees Celsius. That is our room temperature, right? So under the normal room temperature condition, it will exist as a liquid state. Then what is the boiling point? What is the boiling point of alcohol given here? I mean ethanol given here. It is around 78.37 degrees Celsius. At this particular temperature only it will start boiling. Clear? These are the introduction of properties of ethanol. Now we need to discuss about the chemical reactions or the chemical properties of ethanol in detail. Okay, I hope you understand. Now, what is the structure of ethanol? Structure of ethanol, right? So this is the structural formula of ethanol which we have discussed in detail in the case of IUPAC nomenclature, right? So what you're observing here, 1 and 2 carbon, right? 1 and 2 carbon compound. Then how we need to do the naming here? It is a 2 carbon compound, right? 2 carbon compound. So the word root will be eth. So this is an OH group, right? OH group is a functional group of hydroxy group which will have the more priority. So we need to give the least number of carbon to the attachment of OH group. So I will start the numbering from here. So it will be 1, 2. So our name of this compound will be ethane 1 or simply it is known as the ethanol. Okay, I hope you must have idea about to write down the structure of a compound by giving the IUPAC name, right? So this is the exact structural formula of the ethanol or ethyl alcohol, and this is the condensed formula, which means 2 carbon atoms as well as 5 hydrogen along with an OH group is present in the case of ethyl alcohol or ethanol. Hi Arush, good evening. Okay, Now let us discuss about the chemical properties of the, applications of the ethanol as well as the chemical properties. So what will be the role of ethanol in our life? Any idea? Have you ever seen any application of ethanol in your daily life? So as you can see over here, ethanol is the major part in the case of alcoholic beverages, right? So in most of the alcoholic contents, it will be containing more percentage of ethanol as the one of the component. And due to its effective solvent properties, it will act as a medicinal purpose, right? Medicinal purposes products such as iodine tinctures. Do you have any idea about the iodine tinctures? No, Arush, ethanol and ethanoic acid are two different carbon compounds. In the case of ethanol, it is alcohol group, right? Alcohol functional group. In the case of ethanoic acid, by name itself, it is a carboxylic acid group, which we have already discussed in the case of functional group, right? Yes, iodine tincture means whenever we have any wound in our body, right? So we will add a brown color solution to that. That is known as the iodine tinctures, which is used to cover that wound. Then cough syrups and the numerous tonic formulations, we are using this ethanol as one of the most important component. Clear? Now let us discuss about the chemical reactions of the ethanol. We will be starting with the first reaction, the reaction of ethanol with sodium. As we already know, sodium is a metal, right? So what you are accepting the product as a resultant of ethanol with sodium. So this is our reaction, right? This is our ethanol molecule. Whenever I am treating with the sodium metal, right? Sodium metal, we will be getting the sodium ethoxide molecule, which is an ether, right? So this is an ether along with hydrogen atom. So this will be the reaction. Treating with ethanol with sodium, we will get the sodium ethoxide. Clear? So this reaction is very important. The balanced chemical equation for this reaction is very important. The reaction of ethanol with sodium metal. Is that clear? Just let me know. Fine. Now let us discuss about the another type of reaction with the ethanol. So what do you mean by unsaturated hydrocarbons? Unsaturated hydrocarbons. Again, we have discussed in the classification of hydrocarbons, right? What do you mean by the unsaturated hydrocarbons? What is the nature of bonds in between the carbon, whether it is single bond, double bond or triple bond? Okay, I hope my question is clear. It must be contain either double bond, right? Either double bond or triple bond in between carbon atoms. So what we are doing here, we are taking our ethanol molecule, right? We are taking our ethanol molecule. Then we are heating at this specified temperature, 443 Kelvin, in the presence of excess of concentrated sulfuric acid. This reaction is very specific. It will happen at the temperature of 443 Kelvin and in the presence of sulfuric acid only. So what is happening here? It will undergo dehydration. What do you mean by dehydration? Any idea? Dehydration means removal of water, right? Removal of water. So what you are observing here, there is an OH group in the case of ethanol molecule, right? OH group in the case of ethanol molecule. So this OH group as well as one of the hydrogen from the CH3 will combine together to form water molecule here, right? It is releasing water molecule from the OH as well as one of the hydrogen from the CH3 part. So what you are getting here, this bond will form a double bond here, which means we can produce ethene, our double bonded carbon, right? This is an unsaturated hydrocarbon. So we can produce ethene from the ethanol by treating with concentrated, hot concentrated H₂SO₄ or concentrated H₂SO₄ at 443 Kelvin. Is that clear? Yes, the loss of water crystal is known as a dehydration part. So in the case of this particular reaction, what we are observing, the OH and hydrogen from this part will combine to form water molecule. They are removing water molecule from the compound to form an unsaturated hydrocarbon. Most probably it will be the ethene molecule. Clear? This is a specific reaction for the case of ethanol molecule at the temperature of 443 Kelvin and in the presence of excess of concentrated sulfuric acid. Is that clear? So that's all about a part of ethanol compound. Ethanol is one of the important alcoholic compound of the carbon containing 2 carbon atoms, right? So what we have discussed about the ethanol, we have seen the structure of ethanol, right? We have seen the structure of ethanol. Then we have discussed the 2 type of reaction. One is the reaction of ethanol with the sodium. It will be producing ether molecule, sodium ethoxide, right? The second one is the reaction of this ethanol to produce the unsaturated hydrocarbons. When we are treating with a hot excess concentrated sulfuric acid, it will produce ethene. Okay, I hope you understand about the reactions as well as properties of the ethanol. Now we are moving to the next carbon compound that is known as the ethanoic acid. So what will be the functional group present in the case of ethanoic acid? The name itself, oic acid, which is the suffix for the part, functional group. Just read from the slide also, no, it is given carboxylic acid group. So the common name of this compound is known as acetic acid, or it is also known as ethanoic acid. So what do you mean by the acetic acid, which we are using in our kitchen, right, as a vinegar? Vinegar is a common name of acetic acid or the ethanoic acid, which means containing 2 carbon atoms, right? Ethene. Eth stands for the 2 carbon atoms. So this is the ethanoic acid. Then what about the properties? So it is containing CH₃COOH group. This COOH group is known as the carboxylic acid part, right? Then what about the property? Again, it is also a colorless liquid, as same as that of the ethanol, right? Then it has a pungent smell and a sour taste. Pungent smell and a sour taste, right? Or we can write it as it is a vinegar smell. So that you can easily understand what you mean by the acetic acid. It is similar to that of the vinegar, which we are using in our kitchen. So it has a melting point of 16 degrees Celsius as well as boiling point of 118 degrees Celsius. These are the introduction of the properties of the ethanoic acid. Now let us see the structure of ethanoic acid. Structure of ethanoic acid. As we already know, it must be containing a carboxyl group. This is COOH group. This is C double bond OOH. This part is known as the carboxylic acid group, right? So in the case of ethanoic acid, this is the methyl product, right? CH₃COOH. So this will be the structural formula of the ethanoic acid, or this will be the condensed structural formula of the ethanoic acid. Clear? So just explain the structure here. This is a methyl group attached with the carboxylic acid group. So that is why they are acting as an acid here, right? It has the acidic properties. Clear? Now let us discuss about the applications of ethanoic acid or the acetic acid. What will be the applications? So what will be the applications of acetic acid or vinegar? Yes, food preservation, right? So vinegar, which we are used in the case of in our home, whenever we are making pickles or something, we are used as a preservative there, right? Preservative which must be containing 5 to 8% of acetic acid in water. That is known as the vinegar. So it serves as a widely utilized preservatives for the pickles. Then what else? Have you ever familiar with the term glacial acetic acid? Glacial acetic acid. Yes. So in the case of acetic acid, it has a property like that. It has a tendency to freeze in cold climates, right? It has a tendency to freeze in cold climates. That's why it is termed as a glacial acetic acid, right? Glacial acetic acid, because they are freezing in the very cold climates. That's why the name glacial acetic acid comes here with a melting point of 290 Kelvin. Clear? Then the last property of the application of the ethanoic acid like that. Unlike strong mineral acids such as HCl, carboxylic acid, the carboxylic acid exhibit weak acidic properties as they are not completely ionized. So for example, if you are asking about the HCl molecule, right? HCl molecule. So what you are observing, if you are putting in the water, it will be dissociated into H plus and Cl minus, right? It will be completely dissociated. But in the case of CH₃COH, we are expecting that it will be dissociated from acetate ion, CH₃CO. Right, CH₃CO minus plus H plus ion, but in the actual practice, it is not completely ionized, right? It's not completely ionized. That's why they are act as the weak acid here. Vinegar is a common example of acetic acid, right? In which vinegar is it is containing about 5 to 8% of acetic acid in water. Now, what are the uses again? It's like a preservative and flavoring agent in the food industry, and also it is used in the manufacture of synthetic fibers, plastics, and as a solvent in various chemical processes. So when you are discussing about the chemical process in detail about the grade 11 or 12, you will be discussing about the what is the exact use of ethanoic acid in these particular reactions. Then it is employed in the production of esters which are used in perfumes and solvents. So in the last class, I think in the case of isomerism part, we have discussed about the esterification reaction, right? Esterification reaction, which means ethanol and ethanoic acid has combined to form an ester. This ester is having a pleasant fruity smell which is used in the case of perfumes. So these ethanoic acid is also used for the production of esters which is used in the perfumes and as solvents. Clear? These are the application or the uses of ethanoic acid in the daily life. Is that clear? Now let us discuss about the major important reaction of the ethanoic acid with base. So what do you mean by base? We have studied in the second chapter, right? Acid, bases and salts. So what is the capability of bases? It will be giving OH minus ion, right? It will be giving OH minus ion. So for example, here I am taking acetic acid, right? Acetic acid or ethanoic acid, and I am taking base as the sodium hydroxide here, NaOH, right? So what you are getting here, these will react with each other, right? These OH and this hydrogen will react to form the water here as the byproduct. Then the CH₃CO acetate plus sodium will be forming sodium acetate ion. Clear? Is that clear? So this is a reaction of ethanoic acid with base. Here we are using the base as the NaOH, sodium hydroxide, right? So this sodium hydroxide as well as our ethanoic acid or acetic acid react to form by releasing a mole of water, right? OH and H will combine to form the water as a byproduct, along with the main product, sodium acetate, is forming. So this is very important reaction as related to the ethanoic acid part, right? Reaction with the base. Now let us discuss about the last reaction of ethanoic acid with carbonates and hydrogen carbonates. So what will be the formula of carbonates? Again, we have already discussed in the case of first chapter, chemical reactions and equations. What will be the formula of carbonates? Yes, carbonate is an ion, right? So we need to mention their charge also. So in the case of carbonates, it will be CO3. Are you sure? Correct, but we need to focus on the charge also. It will be CO3 2 minus, right? CO3 2 minus. It is the carbonate. And what about the case of hydrogen carbonate or bicarbonate? It will be HCO3 with minus charge. Clear? So what we are seeing here, this is our acetic acid, right? Acetic acid. So I am taking a carbonate compound here as sodium carbonate. So what we are observing here, these will combine together to form sodium acetate, right? This is a sodium acetate. Then water plus carbon dioxide. Clear? Sodium acetate, water plus carbon dioxide. So if you are treating carbonates or hydrogen carbonates or the bicarbonates with the ethanoic acid, the byproducts will be carbon dioxide and water. Clear? So again, this is a bicarbonate, right? HCO3 is the bicarbonate. Generally, the HCO3 is having the charge of -1, right? Then it will combine with the Na plus to form a compound like sodium bicarbonate or sodium hydrogen carbonate. Do you have any common name for this compound, NaCO3? Okay, just think about that. What will be the common name of this compound? We have discussed in the second chapter. So acetic acid plus sodium bicarbonate to form sodium acetate plus water plus carbon dioxide. Clear? Now we are moving to the last important reaction which we have already discussed about the esterification reaction, right? Esterification reaction. So what do you mean by the esterification? We are treating alcohol with the carboxylic acid, right? Alcohol with the carboxylic acid. It will react to form an ester compound. So what will be the ester? Functional group in the ester, it will be COO group, right? COO group. For example, if you are taking CH₃COOH, right? CH₃COOH, that is our ethanoic acid plus ethanol, alcohol, right? So this will be our product forming and this will be an ester. Clear? This is the general formula of the esterification. If an acid or alcohol combine to form an ester, if you are particularly using ethanoic acid as well as ethanol, it will be forming corresponding ester. Is that clear? Yes, this is the reaction. Now what we need to do, we know that only this compound is forming, right? Only this one is the functional group. So what we need to do, this hydrogen atom and this OH should be removed as a water. Then what is remaining here? CH₃CO is present here, right? Hydrogen is removed from the acid. Acid is the one which is having the property to donate H plus ion. So this H is donated. The remaining will be CH₃CO. Then what is here in the case of C₂H₅OH? OH is again removed, right, as a part of water. So remaining it will be C₂H₅. So this will be our resulting product. Arish, is there any doubt? Is there any doubt? Okay, fine. Yes, this is the ester compound and its name is ethyl ethanoate. Now, what is the application of esterification in our daily life? As we already discussed, right? Ester is having the pleasant fruity smell, so which we are used in the case of perfume production as well as flavor enhancement. Then also in the case of some of the paints and inks and adhesives, they are used as the solvents, right? Then they are important in the manufacture of plastic and synthetic fibers. So esterification is very important. More specifically, we are discussing about the esterification of ethanoic acid as well as ethanol. They will be forming ethyl ethanoate as the ester, right? So they are commonly used in the case of perfume production because of their pleasant fruity smell. Clear? Yes, again, they are repeating the same only here. If you are taking sodium hydroxide, right? Sodium hydroxide as an alkali here, these esters undergo a chemical transformation to form sodium salt of carboxylic acid, right? As we already know, for example, so this will be our ethyl ethanoate, right? The ester formed as a result of ethanoic acid and ethanol. So when we are treating this with the excess of alkali like NaOH, what it is forming? It will be forming the sodium salt of carboxylic acid and reverting the alcohol here. Okay, did you understand this point? So for example, when we are subjecting the resulting ester here, right, resulting ester with the NaOH as an alkali, what is forming here? The esters undergo a chemical transformation. So it will be taking this Na towards it will form the sodium acetate, right, sodium acetate, and it will be reverting the alcohol given there, it will be ethanol. That is the same sentence which is given in here, is reverting to alcohol and the sodium salt of carboxylic acid. Is that clear? Is there any about this explanation or this reaction? So this reaction is termed as a saponification in the detergent as well as soap forming process or soap making process. Clear? So esterification, and we are expanding the esterification. When we are adding alkali to the corresponding ester, we can produce soaps. That process is known as a saponification given here, and the reaction is given here as the saponification example. I hope you understand. Then again, if you are taking sodium or potassium salts, it will be forming long chain carboxylic acid in the case of soaps. Okay, I hope you understand. This is all about the carbon and its compounds chapter. We have discussed about the hybridization, right? Hybridization part of the carbon compound. Then we have discussed about the IUPAC nomenclature of different compounds, right? We have classified the hydrocarbons into saturated and unsaturated hydrocarbons. And also we have seen some functional groups also, right? Then we have gone through the isomerism part. Finally, we are moving to the chemical properties of carbon compounds. And the last one, it is about the ethanol and ethanoic acid. I hope you guys have watched all the recorded session for this chapter. This will be the last concept session for this chapter, carbon and its compounds. Okay, now let us practice some questions based on the topics we have covered in this class. Here is our first question. So what will be the answer for this question? What is the common name of ethanoic acid? Yes, option C, right? Acetic acid or common vinegar. So option C will be our correct answer. Here is our next question. What is the byproduct of the esterification reaction between ethanol and ethanoic acid? Read the question carefully. It is asking about the byproduct, not about the major product. Yes, water will be our product, right? Whenever we are treating ethanol, CH3, CH₂OH plus CH₃COOH, ethanoic acid, it will be producing ethyl ethanoate as well as water molecule. So option A will be our correct answer. Here is our next question. What is the product formed when ethanoic acid reacts with sodium hydroxide? Read the question properly. What is the product formed when ethanoic acid reacts with sodium hydroxide? Okay, what will be the answer? Are you sure? So what is the reaction given here? Ethanoic acid, right? So CH₃COOH, this is the ethanoic acid. We need to treat it with the NaOH, sodium hydroxide with base. We have seen the first reaction. So what you are observing here, hydrogen from acid and OH from the base, right? Neutralization reaction. It will be remove as water, right? Remove as water. Then producing the major product as CH3COONA plus H2O. So this CH3COONA is known as we already know how to write down the chemical formula of a compound, right? CH3COONA is known as the sodium acetate. So option A will be our correct answer, sodium acetate plus water. Arush, is that clear now? Okay, fine. Here is our next question. What is the product formed when ethanol reacts with sodium metal? First reaction we have discussed in this class, the reaction of ethanol with metals, right? Are you sure about the answer? Here the answer is sodium ethoxide plus hydrogen gas. So what is the reaction here? Ethanol, CH3CH₂OH or C₂H₅OH, right? Plus sodium, it will be forming clear? Is that clear? So what is the name of this compound? CH2ONA. Functional group is oxygen here. So it will be an ether having the name of sodium ethoxide along with hydrogen. Here is our next question. What is ethanol commonly used for? For different applications for the compound is given here. We need to identify the one which is the correct application for the ethanol. Yes, as a solvent and in alcoholic beverages, right? So most commonly we are using the ethanol as a alcohol content in the case of beverages. Okay. Here is the next question. What type of hydrocarbon is formed when ethanol is dehydrated? Ethanol is dehydrated. Read the question carefully. We are dehydrating the ethanol. So how it is possible to get the ethanol from the dehydration? And the question it is given, what type of hydrocarbon? No answers? From the options itself, we can just remove the alcohols, right? Because these are not hydrocarbons. So we can just check with whether it is alkane, alkene, or alkyne. Arush, are you sure it is alkyne? Alkene is our correct answer. So what is the reaction here? Ethanol, right? Ethanol is heating with hot concentrated H₂SO₄ or 443 Kelvin. Concentrated H₂SO₄, right? So what we are observing here, it will be removing water molecule, right? It will be removing water molecule. One of the hydrogen from the CH3 and the OH group will combine to form water molecule. That is known as the dehydration, removal of water. So it will be forming CH2 double bond CH2. Unsaturated hydrocarbon with double bond is known as the alkene, or here it is specifically ethene. Clear? So what will be the exact answer? It will be alkene only. Arush, is that clear? It's not at all that much difficult. You need to watch the recorded session after completing the class, and only we can remember all the reactions. Whenever we are seeing for the first time, it will be feel like that it will be very difficult. No, it is not at all difficult. So let's quickly summarize the topic that we have covered in this class. So first we have seen the properties of ethanol, right? Ethanol. So it is volatile, colorless liquid, miscible with water, right? If you are adding along with the water, it will be completely miscible. Then flammable and used in the beverages, solvents, and as biofuel. So these are the physical properties and the applications of the ethanol. Then reaction, first reaction we have seen, right? It forms sodium ethoxide and hydrogen gas with the sodium metal, right? Sodium metal. And in the case of CH3, CH2OH, it will act as a weakly acidic nature. Then the last one, the reaction of ethanol with the ethanol to give the unsaturated hydrocarbons. We have seen the last reaction. If you are treating with the hot concentrated sulfuric acid, it will be forming the corresponding compound or the alkenes. Then the next compound, ethanoic acid, colorless liquid with a pungent smell, weak acid because of the low dissociation in the water, and it is soluble in the water. Then what is the reaction? Reaction with base, right? It will neutralize the bases to form corresponding salt as well as water, neutralization product. Clear? Then the last one, the reaction with carbonates and bicarbonates, CO3 2 minus as well as HCO3 minus. It will be forming salt, water, and carbon dioxide. So most probably it will be sodium salt or carboxylic acid. Then the last reaction is about the esterification reaction. What you are observing here, when we are treating alcohol plus acid, it will be forming a ester here. Here we are discussing about the reaction of ethanol as well as ethanoic acid. It will be forming a sweet smelling ester which is used in the perfumes. Clear? So these are the major topics we have covered in this class. So this will be the last concept class for this particular chapter, carbon and its compounds. I hope you understand, and I believe I have covered almost all the important topics from this chapter. In the case of carbon and its compounds, the IUPAC nomenclature is very important. This is the basics in the case of organic chemistry when we are going to discuss in the grade 11 and 12. So just go through that. If you have any difficulty in any part of this chapter, we can discuss in the next class. Okay, I am not decided yet which topic you want to take me. The remaining two chapters, I think it is chemical bonding as well as periodic table. Which one you want? the upcoming next 2 classes, I will be discussing about the practice questions, more CBSE as well as board exam questions as well as JEE main question also from the chapter carbon and its compounds. So try to find out that, try to watch all the recorded session for this particular session. I have covered through 7 lectures, I think. So if you face any difficulty in any part of the chapter, just let me know in the next class. Okay, periodic classification, right? About the periodic table. Okay, I will try to cover that chapter. Arush, do you have the metallurgy part in the syllabus? And metallurgy we have already discussed in the case of metals and non-metals, right? It is a part of metals and non-metals. The half part of the metals and non-metals will be the metallurgy part. Extraction of metals, purification, which we have already discussed the last chapter. And then chemical bonding and SBD, it is hybridization, not configuration, right? So sp3d, sp3 and hybridization will be discussed detail in the chemical bonding chapter. So metallurgy is a vast area in the case of inorganic chemistry. So according to your syllabus, we need to discuss on those reactions only which we have discussed in the metals and non-metals chapter. So I will try to cover the periodic classification, periodic table chapter first. Then after that we can discuss about the chemical bonding. Fine? Sajid, what is your doubt? It's about the sp2 hybridization. Okay, in the first lecture of this chapter, I have discussed about the type of hybridization, sp, sp2 and sp3 hybridization. So try to watch those recorded session if possible. Is there any other doubts, or can we wind up the session for today? Okay, fine. Try to watch all the recorded session for this chapter. Then if you are facing any difficulty in IUPAC nomenclature part or isomerism part, let us discuss in the next class also. I will be coming back with a few more questions in the chapter carbon and its compounds. So thank you so much all of you. See you in the next class. Bye bye.